Alright, welcome back. Now in this video, I'm going to go through UNO's Primary School Practice Set 1 Foundation Science Booklet B. Only selected questions. This video is meant for my Foundation Science students in 2022. And I'll be going through questions 23 onwards. Now for those who are watching this at a different time or just for your own revision, feel free to always pause the video at the questions before moving on to listen to the explanation. Let's get started. Right, my students should have completed the work on Monday, 17 October 2022, and today they will be going through the corrections for this. CD conducted an experiment using two identical jars as shown in the setup below. So there's a jar P and jar S, and it's on a balance. Alright? And when it's on a balance like this, something like that, trying to balance itself, then of course something with more mass, if let's say there's more mass here, it will go down this way, right? If there's more mass on this side, it will go down this way. If it remains level to the table or to the ground, that means that both sides have the same amount of mass. This is what I'm seeing here. It is level. Okay? So what does this tell me? I see a jar containing 250 cubic centimeter of air, another jar containing 50 cubic centimeter of air. So what will I say? Air is a type of something that has mass and occupies space, so must be matter. Because matter has mass, this is what the balance is showing, and occupies space. That's what the volume here shows, occupying a certain amount of space inside. Right, there's a space, the air are occupied inside. Circle the correct answer. So there's only one answer to circle. CD pumped another 100 cubic centimeter of air into jar S. Okay, so the side with jar S moved downwards. Now, if it moves downwards, this means that there is more mass. However, the volumes remain unchanged. This is a glass container, it's not a balloon. A balloon is kind of stretchy, right? So when you pump air inside, it can inflate, become bigger. But if this is glass, the glass is a solid, and this solid is stiff, and it doesn't expand the way a balloon does. So when you pump air inside, actually air will be compressed inside. Even if I pump more air inside, I can put in another 100 cubic centimeter of air, and the total volume here is still 250 cubic centimeter. Therefore, the volume of the gas of the air in jar S is equal to 250. Those who choose more than, you thought that 250 plus 100 gives you 350. That is not correct because the volume in this glass jar will remain unchanged. Okay, next question. 3 conditions must be present for plants to make food. One of the conditions is light. Now, of course, this question, don't have to worry, it will not be tested in your P5 end of year paper in 2022 because you didn't learn this thing about photosynthesis. I'll briefly go over the question and answer in case it's a primary 6 student watching this and you're using this for your PSLE revision. Now, let's go through the formula for photosynthesis. You need to have carbon dioxide gas plus water. This is a short form for water, short form for carbon dioxide gas, in the presence of light and chlorophyll, and you will get food or sugar plus oxygen gas. So they say that one condition is light, so light must be present. So conditions are these things here. So what else? Do I see carbon dioxide here? Yes, I see carbon dioxide. Do I see water here? Yes, I see water. Now heat is not necessary, so I ignore this. Oxygen and sugar are not the conditions for photosynthesis. Food is actually sugar. They are actually the results of photosynthesis. They are the product of photosynthesis. The setup shows the amount of gas collected. So if there's photosynthesis, there will be oxygen gas inside. See, oxygen being produced. Alright, and there's light, there's plant. So light here. Plant has chlorophyll, right? There's water, and of course, in water there's some dissolved carbon dioxide. So there is photosynthesis going on. This gas collected will be oxygen. Okay, the spelling for oxygen is this. Which of the following shows the results when the lamp was placed nearer? Lamp placed nearer means that there's more light. If there's more light, the rate of photosynthesis will increase. Therefore, there's more oxygen being produced. And since oxygen is a gas and gas occupies space, therefore it occupies more space. It should be this answer. As I mentioned, if you are my student and you got this wrong this year, 2022, don't worry about this. You will not be tested. If you got it wrong, it's not your fault. You haven't learned this yet. Next one, question 25. Now, next question. David poured 50 ml of water at different temperatures into 3 identical containers A, B, and C. Different temperatures. This tells me this topic could be about heat energy. So 40, 60, 80. Now, they are the same amount of each, right? Same amount of water. You can see the water level is the same. See, water level is the same across. So if the amount of water is the same, but this one has higher temperature, this one has less temperature, this means this one has more heat energy. This one have the most heat energy, and this one have the least amount of heat energy. Okay. Now he measured the amount of water left in each container after 5 hours. So his results are shown below. Now container A, alright, water at the start of the experiment is this, at the end, so this may not be about heat energy at this moment. Alright, it could be about evaporation. Why? We can see the amount at first was this, amount at the end was less. If there is less water, where would the water have gone? Can't be David has taken a sip of the water, right? So it must have evaporated. So here I see that there's the most amount of evaporation. This is the least amount of evaporation. So what's the amount of water left in B after 5 hours? Since the temperature is in between 40 and 80, I'll take it as this number should be somewhere in between. So any number that you write that's in between these two, okay, roughly, like 30. Okay, 39 is a bit nearer to this. 44 is a bit too near to this. I think a number roughly about, let's do a mathematical one. I plus these two numbers, I will get my 84. Then 83 divided by 2, that gives me 41 and a half. Alright, so roughly between 40 to 42, 43, any of these answers should be fine. But even if the answer is 44 or 39, I will still accept it. But if the answer is 45 or higher, or 38 or lower, it's definitely wrong. So this answer here, my answer will be roughly, let's say 42 ml. I'll expect anything between 39 to 44, okay, acceptable. Why is there less water after 5 hours? This should be a full stop. Why is there less water after 5 hours? Well, the water evaporated. That's why. Now, name 2 other variables that must be kept the same to ensure it's a fair test. Now, there are 3 factors that affect the rate of evaporation, and you can remember them by WET. W will be the wind condition. There's more wind, things dry faster. This will be the exposed surface area. And last one here will be the temperature. Now in this case, the temperature is changed, right? So this is the change variable. So the 2 variables that are kept the same definitely would be the wind and the exposed surface area. So you can say the amount of wind and the, let's write exposed surface area. Okay? By the way, if you don't remember, right, what's exposed surface area? This is the exposed surface area, the amount that's exposed to the environment. Raise my ruler and measure. This is roughly 2.4 cm here. Let's check. 2.4 cm as well. And here also 2.4 cm there. The exposed surface area for all 3 containers are exactly the same. And since they are in the same location, the amount of wind they all experience will be the same. That's the meaning of kept the same. Joseph's family was having a hot pot dinner and his mother brought out a tub of ice cream from the freezer. Yummy. Okay? But of course, I don't recommend eating hot and cold stuff back to back. I like you to get a stomachache. Now, Joseph observed there were white fumes rising from both the tub of ice cream and the hot pot. This is a tough one to answer, even for those taking the standard science. So I hope that you will pay attention to this. State one similarity between the white fumes and the ice cream tub. Okay, from the ice cream tub and the white fume from the hot pot. So these white fumes they are tiny water droplets. That's a similarity. They are all tiny water droplets. But the way they came about is a bit different. But they are all tiny water droplets. That is the similarity part. Now for the difference. State one difference between the white fumes from the ice cream tub and the white fume from the hot pot. Now how did these white fumes here appear? Now remember, firstly, there's always water vapor in the air surrounding anything, surrounding you, surrounding my hands, surrounding this. Let's talk about this first. Alright, for condensation to happen, so in this case, in the case of the white fumes, it's all about condensation of water vapor. The only difference is where the water vapor comes from. In this case here, the water vapor will be from the surroundings. It's the surrounding water vapor in the air that condenses when they touch the cooler air that is nearer to the ice cream. In this case here, the water vapor came from the hot pot. The hot water vapor that rises touches the cooler air of the surrounding. Imagine a hot pot, maybe a temperature of this could be maybe 90 degrees Celsius, I don't know, 100 degrees Celsius. So the surrounding is about 30 degrees Celsius. So which one is cooler? Surrounding, obviously, right? So this one becomes the cooler surface. In this case here, ice cream, let's say, is very cold, 0 degrees Celsius. Actually, it's lower than that. But I don't want to use a negative number. So if this is 0 degrees Celsius and the surrounding temperature is still the same, 30 degrees Celsius, which one is the cooler one? This, of course, lower temperature. So of course, then the condensation will happen around the top of ice cream, including seeing some white stuff on the box of ice cream itself. So what's the difference between the white fumes from the ice cream tub? I will say that the water vapor that condensed into the white fumes from the ice cream tub came from the